In the infinite black, where stars are distant whispers and silence stretches beyond comprehension, the universe drifts on in solemn indifference. Space is not empty. It is a vast, cold expanse where even light feels slow, and time seems to stretch into an eternal pause. Among the scattered pinpricks of starlight, tiny travelers sail unnoticed rocks, ice and dust from realms beyond our solar system, carrying with them stories older than our sun. And now, a new presence appears. Known to astronomers as 3I Ateles, it glides along a trajectory that will bring it through the outskirts of our solar system. Alone, such an object might be remarkable, a silent messenger from another star. Yet in the shadows behind it, faint signals suggest a far stranger reality. 3I Ateles is not solitary. A swarm, a hidden entourage of unseen companions, drifts in its wake, moving with eerie synchrony. Like echoes of a cosmic choir we are only beginning to hear. Imagine the vast distances between stars. Even at the speed of light, messages from one sun to another take years, decades, sometimes centuries to traverse the void. And yet, this tiny object, a fragment of some otherworldly system, has traveled light years with a precision that defies ordinary chance. Its companions are smaller, darker, and more elusive, slipping through detection like shadows in a midnight fog. The cosmos has always been populated with hazards, but rarely do they arrive in formations, coordinated, almost purposeful. Astronomers first noticed the subtle anomalies as tiny deviations in 3I Ateles's path. At first, they were dismissed, mere noise in the data, an artifact of imperfect observation. But repeated measurements confirmed it. There were additional masses trailing close behind. The numbers did not lie. Each tiny companion, though invisible to the naked eye, cast immeasurable gravitational influence. Like a swarm of bees unseen in a garden, they accompanied the lone traveler, a silent procession crossing the gulf between stars. What does it mean to observe something so alien? To know that beyond our sun, beyond familiar planets and comets, there exist objects with origins and trajectories we cannot fully trace. Humanity has always looked to the skies for signs, for stories, for warnings, for wonder. And now, in this quiet moment of discovery, we confront both awe and unease. The swarm implies organization, a pattern in a place we assume is random. Are these objects remnants of a shattered planet, fragments of another solar system torn apart by forces unimaginable? Or are they simply the byproduct of cosmic chance, appearing now in a brief alignment visible to our instruments? Even as scientists calibrate their telescopes, calculate orbits, and scan for further anomalies, a feeling of smallness takes hold. Earth is a tiny island of warmth and life, orbiting its sun with meticulous rhythm. Beyond the outer planets, past the Kuiper Belt and the scattered debris of our system, a visitor approaches, not a single rock, but a gathering of objects that hints at a narrative far larger than ourselves. And in that vastness, there is no guarantee of notice, of interaction, or even of survival. The swarm's existence raises questions both practical and philosophical. If 3I Atlas and its companions were to pass closer, what forces might they carry? Could they bring material that has never touched our sun? Chemical compounds or cosmic dust that could seed new reactions in the outer planets? Or could they pose a hidden risk, small objects traveling at tens of kilometers per second, capable of impact events that reshape continents? Even in the realm of theoretical risk, the imagination struggles to hold the scale, the speed, and the unpredictability of such a cosmic encounter. Yet there is beauty in this uncertainty. In observing the unknown, humans discover perspective. We are creatures of gravity-bound bodies and limited lifespans, staring at travelers that have crossed the void for millennia. Each fragment of the swarm tells a story older than recorded history, a tale of formation, collision, and exile. And in their silent procession, there is an unexpected poetry, a reminder that motion, even in darkness, carries meaning, even if we do not yet understand it. History has prepared us, in ways subtle and profound, to interpret such cosmic events. Ancient astronomers and stargazers, tracking comets across the night sky, recorded patterns in fear and fascination. They saw omens in the heavens, signs that the universe could intervene in mortal affairs. Today, our instruments extend that ancient vigilance, translating light and movement into data, probability, and predictive modeling. Yet even with all our knowledge, the arrival of a swarm from another star evokes something older than science, the shiver of recognition that the cosmos is larger, stranger, and more intricate than our daily lives could ever convey. The approach of 3I Atlas and its entourage is a reminder of scale. Distances that boggle the mind, speeds that defy intuition, and forces that dwarf human comprehension converge into a single observable event. It is a humbling spectacle, a whisper from the dark that life is fleeting, systems are fragile, and even the void itself carries surprises. And so, as 3I Atlas enters our cosmic neighborhood, the question lingers: what are these companions? Are they silent remnants of a destroyed world, debris caught in a celestial dance, or something else entirely, something we have yet to imagine? For now, we watch, measure, and calculate, knowing that observation is both our shield and our invitation. The universe offers no certainty, only glimpses, patterns, and the slow unfolding of phenomena that challenge understanding. The dark does not speak in words, yet it whispers constantly. In these whispers, humanity learns vigilance, patience, and wonder. Each interstellar visitor, each unseen companion, is a messenger from the cosmos, a reminder that we are not alone, not merely in life, but in the ongoing drama of matter, energy, and motion that unfolds across the stars. And as we continue to track the approaching swarm, we feel both awe and unease. The universe stretches infinitely, indifferent yet full of story. And in the silence, 3I, Thales, and its hidden canyons drift closer, whispering secrets we are only beginning to hear. But the story does not end with their arrival. To understand what we observe, we must first name it, give identity to the unknown. Only then can we confront the questions it poses, not just to science, but to our imagination and our future. On a quiet night, as telescopes swept the heavens in their endless vigil, a faint trace appeared on the screens of astronomers. A speck of light, almost lost in the static of infinity, was moving just differently enough to warrant a second look. What they were seeing was not an ordinary comet, nor a familiar asteroid that had wandered from the Kuiper Belt. This was something stranger, something rare. The official designation would come later, 3I Tla, but in that moment, it was simply the unknown, a visitor breaking the boundaries of our solar system. The discovery carried echoes of earlier surprises. Just a few years before, the world had been captivated by the arrival of a mysterious object named Oumuamua. Unlike anything previously catalogued, it was long and thin, tumbling end over end as it hurtled past the sun. Its path revealed its origin, not from our solar system, but from the deep interstellar void. It was the first of its kind ever observed. Some scientists suggested it was a shard of rock, others a fragment of ice, and still others wondered if it could be something engineered, a probe cloaked in the guise of nature. Then came Borisov, the second interstellar interloper, catalogued as 2I Borisov, a more conventional comet in appearance, with a long gaseous tail shimmering as it raced past the sun. Unlike Oumuamua, Borisov looked familiar, behaving as comets should, but its trajectory told the same story. It too had come from beyond. Two arrivals in quick succession, where once we had expected none. The cosmos, it seemed, was more crowded with wanderers than we had imagined. So when 3I Atlas appeared, it was not entirely without precedent. But precedent does not erase wonder. nor does it silence unease. Astronomers quickly realized this was no ordinary body. Its brightness, its velocity, and the subtle irregularities in its path made it stand apart. Instruments tracked it night after night, and as the data accumulated, a picture began to form. This was the third confirmed interstellar object in human history. And unlike the first two, it did not travel alone. What drew attention first was its sheer faintness, the way it flickered against the dark as if hesitant to reveal itself. Telescopes had to peer deeper, stacking exposures and stretching their sensitivity to detect its trace. Yet once identified, its movement told the truth. Its orbit was hyperbolic, unbound by the sun's gravity. This was a traveler that would come, pass, and leave again, forever beyond our reach once it vanished back into the void. Such trajectories do not lie. This was no member of our planetary family. This was a stranger. But why, some wondered, are we seeing so many now? For centuries, interstellar visitors must have crossed through our neighborhood unseen. Were our instruments simply too blind? Our records too thin? Or was there something more? A shift in the cosmic winds? A reason that wanderers now seem to arrive in succession, almost in procession? Scientists offered theories. Perhaps interstellar objects are more common than we believed, but technology has finally caught up, allowing us to see them at last. Perhaps stellar nurseries, far away, are flinging debris outward, casting fragments like sparks across the galaxy, and we are only now in the path of one such stream. Or perhaps it is chance, coincidence magnified by our own attentiveness. Yet the unease lingers, for each answer leads to further questions, and the timing, to some, feels uncanny. 3.1a drew more scrutiny than its predecessors because of what came next, the discovery of its companions. Tiny, dark, and difficult to observe, they trailed along its path as though fragments of a greater whole. Were they pieces broken from the main body? Were they smaller travelers bound together by a shared origin? Or were they clues to a story we have not yet pieced together of cosmic collisions, shattered systems, or even artificial dispersal? To name something is to begin to know it. The 3I in 3I Celia's marks it as the third interstellar object ever observed. LS refers to the survey telescope that spotted it, the Asteroid Terrestrial Impact Last Alert System, based in Hawaii. But names are only labels, not explanations. They do not tell us what the object is, only that we have seen it, caught for a fleeting moment in our planetary gaze. Like a ship glimpsed on a dark horizon, its passing reveals existence, not intent. And so, the story of 3I begins not with certainty, but with mystery. It reminds us that the universe is not a static place. It is restless, dynamic, and ever-shifting, scattering fragments of creation across the gulfs of interstellar space. Each one carries history, perhaps of stars long extinguished, perhaps of planets destroyed. Each one is a puzzle, a silent question flung into the dark. We stand at the threshold of this mystery, peering into the night, recording coordinates and luminosities, while behind those numbers hides a truth we have not yet uncovered. What is 3I Atlas? What stories do its companions carry? Is this a natural phenomenon? Or is it something more, something we have yet to imagine? For now, it drifts nearer, silent but undeniable, a reminder that the cosmos is alive with motion. It is not a painting, fixed and still, but a river full of currents we barely comprehend. But to understand a stranger, we must not only name it, we must recall the moment of encounter, the instant when faint light became revelation. The story continues with the moment of discovery. At first, it was just a suspicion, a faint irregularity in the light curve, a subtle flicker in the telescope's gaze. Astronomers tracking 3I Atlas noticed something unsettling. The object was not entirely alone. Small disturbances appeared in the data, whispers of dim companions following in its wake. At first, these traces were dismissed as noise, the kind of statistical ghost that often haunts the edge of perception. But as the observations piled up, the ghosts did not vanish. They grew sharper, more distinct. What emerged was a picture both extraordinary and troubling, a swarm of smaller bodies trailing alongside the primary object. Fragments, perhaps. That was the most reasonable explanation. Interstellar travelers are not immune to violence. The forces that tear them from their parent stars, the collisions with other cosmic debris, the stresses of gravitational tides, all can fracture a larger body into pieces. A fragmenting object is not unusual. Comets within our own solar system have split apart countless times, leaving strings of icy shards behind them, like breadcrumbs cast into the dark. But these companions did not behave like ordinary debris. Their spacing seemed too consistent, their orbits too tightly clustered. Instead of scattering wildly, they moved in rhythm, a loose but coherent procession. Like a flock of birds riding unseen currents, they kept their distance yet held their formation. And so a question arose. Were these merely fragments, or were they something else? The human imagination is quick to leap beyond the confines of certainty. To some, the swarm looked like the aftermath of cosmic destruction, the shattered remains of a world long ago reduced to dust. To others, it looked like an escort, a retinue moving with quiet purpose. And for a few, the thought whispered that perhaps this was not random at all. Perhaps the swarm was organized. History offered parallels. In the late 1990s, astronomers studying distant stars had detected strange dips in brightness, as though something vast and irregular were crossing their light. The speculation ranged from dust clouds to the most audacious of ideas, megastructures built by alien civilizations. While natural explanations prevailed, the memory lingered. If patterns of light could raise questions about intelligence among the stars, then what should we make of a swarm trailing an interstellar traveler? Still, science must tread carefully. Telescopes strain to resolve the faint points, to track their movements against the background stars. Each observation carried the risk of error. Were the companions real, or artifacts of the instruments themselves? Repeated studies confirmed they were indeed real. Small, faint, but undeniably present. Some models suggested they were icy shards, broken off when 3I LACC, close to some stellar furnace in its distant past. Others proposed they might be darker bodies, captured in the object's weak gravitational field, drifting like satellites around a drifting host. Both explanations carried weight. Both preserved the safety of natural law. And yet, the unease remained. For the swarm's arrangement still looked less like chaos and more like choreography. Imagine for a moment standing on Earth, looking skyward, and watching as an interstellar procession drifts silently overhead. A primary body, long and cold, leading a retinue of smaller companions. To the naked eye, they would appear like faint stars sliding together across the night. To telescopes, they appear as puzzles, fragments of a story we do not yet know how to read. If they are fragments, then somewhere in their structure lies the record of what shattered them. A catastrophic impact, a tidal tear, a planetary death cry. They would carry the fingerprints of violence written in their fractures and dust. If they are escorts, then what binds them together? Gravity alone seems too weak at such distances. Could they share a common origin, a launch from the same cradle, expelled in unison into the dark? Or could some hidden physics be at work, a subtle resonance guiding their paths? And if they are neither fragments nor escorts, then what are they? For the astronomers who first noticed them, the discovery was both thrilling and unsettling. Data turned into diagrams, diagrams into models. Yet each answer seemed to branch into more questions. Were these companions stable, or would they eventually drift apart, scattering into the solar winds? Could any of them pose a greater risk, their paths deviating just enough to intersect with Earth's orbit? Or would they simply follow their leader, a caravan passing through, indifferent to our fears? The swarm became more than a scientific curiosity. It became a metaphor, a reminder of how little we truly know of the cosmos. For every rule we write, there seems to be an exception waiting to challenge it. For every certainty, a new ambiguity emerges, like a shadow stepping just beyond the edge of light. Somewhere, beyond the reach of telescopes, the swarm continues its journey. We watch it as through a narrow window, seeing only a fragment of its story. We measure its position, its brightness, its faint shimmer against the backdrop of eternity. But its meaning remains elusive. Perhaps it is simply the debris of a cosmic accident. Perhaps it is the natural byproduct of interstellar wandering. Or perhaps, in a universe vast enough to hold both chance and intention, it is something else entirely. And as it draws closer, the questions only grow louder. What is this swarm? Why does it move the way it does? And what message does it carry, written in silence, across the endless dark? To seek answers, we must go back to the moment of encounter when faint light became revelation. The story of 3i Aitali sharpens at its moment of discovery. Before 3i Elisa appeared on our screens, another visitor had already unsettled our understanding of the cosmos. It came in 2017, a fleeting traveler from the dark, and it was given a name from the Hawaiian language, Aumua, a messenger from afar, arriving first. It was unlike anything we had ever seen. As astronomers tracked its path, they realized its orbit could not be explained by the familiar gravitational dance of comets and asteroids. Its trajectory was hyperbolic, unbound, entering our solar system from beyond and destined never to return. It was the first confirmed interstellar object humanity had ever detected. And in its brief passage, it raised more questions than it answered. What made Aumua so strange was not only its origin, but its appearance. Unlike the icy comets that trailed glowing tails as they neared the sun, Oumuamua showed no such plume. Instead, it reflected sunlight in a way that suggested a long, thin body, perhaps cigar-shaped, perhaps a flattened disk. It tumbled as it traveled, flashing and dimming in irregular patterns. Like a shard of glass caught in a beam of light, astronomers tried to fit it into the categories they knew. Was it a fragment of a shattered planet, flung into interstellar space by some ancient collision? Was it a frozen comet, stripped of its outer layers, leaving only a skeletal husk behind? Or was it something more exotic, an interstellar iceberg of hydrogen or nitrogen, slowly evaporating into invisibility? Yet none of these explanations sat comfortably. Each solved part of the puzzle, but left other pieces scattered, unresolved. And then came the greatest anomaly of all, its motion. As Oumuamua left the inner solar system, it accelerated. A tiny but measurable push, as though something unseen was propelling it. Comets can accelerate when sublimating gases burst from their icy surfaces, acting like natural rocket engines. But Oumuamua showed no visible tail, no outgassing, no signs of the jets that could explain the force. It simply sped up, a silent drift made mysterious. For some scientists, this was enough to provoke the unthinkable question. Could Oumuamua be artificial? Could it be a derelict probe, a fragment of alien technology, a relic adrift on a journey across the stars? The idea was controversial, even polarizing. To many, it sounded too much like science fiction. To others, it was precisely what science demanded, to consider even the extraordinary when ordinary answers fail. What mattered most, perhaps, was not the final verdict, for we still have none, but the precedent it set. Oumuamua reminded us that the universe does not always conform to our expectations. It showed us that interstellar visitors are not rare, and that their mysteries may carry clues to events far beyond our own solar history. It also revealed something about ourselves. Our instruments were barely capable of catching Oumuamua as it slipped past. We glimpsed it only after it had already passed the sun, already speeding away, already fading into the deep. By the time we turned our eyes toward it, it was already leaving. Our questions would outlive our ability to answer them. And so, it became a symbol, not just of what we saw, but of what we missed. A messenger that came unbidden, whispered its riddle, and vanished into the abyss. Now, years later, as astronomers chart the path of 3I Atlas and the strange swarm accompanying it, the memory of Oumuamua returns like an echo. Both are interstellar, both unbound. Both carry anomalies that resist easy categorization. And both remind us of how small a window we have into the great unfolding of cosmic events. Is there a pattern here? Are these anomalies simply coincidences, fragments of cosmic debris behaving in ways we do not yet understand? Or are they hints of something larger, a continuity of strangeness, a thread running through the arrivals of these messengers from the stars? We cannot know, not yet. But what is certain is this: every new interstellar visitor sharpens our awareness of the unknown. They are not just rocks drifting in the void. They are reminders that the galaxy is alive with motion, and that some of its stories are written in riddles too fleeting for us to solve. But not all mysteries lie in the present. To understand these strange arrivals, we must also look backward to humanity's long memory of cosmic visitors and the omens written in the sky. When astronomers first noticed the 3I Atlas was not alone, but trailed by smaller, fragment-like companions, the instinct was not to leap toward mystery, but to search for nature's own explanations. For in the history of the cosmos, fragmentation is no stranger. Consider the life of a comet. Born in the icy outskirts of a solar system, it spends eons in frozen slumber, until some gravitational disturbance nudges it onto a path inward. As it approaches its star, sunlight and heat awaken it. Ice sublimates, gases erupt, the surface cracks, stresses build, and sometimes it breaks. Comets have been seen splitting apart under the sun's relentless glare. Their fragments can scatter like glitter across the sky, trailing behind in orbit, like pearls on a cosmic necklace. Astronomers remember the breakup of comet Shoemaker-Levy 9 in 1992, its pieces lining up in a haunting procession, destined to collide with Jupiter in a series of impacts that scarred the gas giant's atmosphere. Could Atlas simply be another such case? A fragile interstellar wanderer, shedding shards as it tumbles through space? To many, this was the first and simplest answer. Yet fragmentation is not the only possible sculptor. The universe has other tools for creating swarms. One is the patient, invisible hand of gravity. Imagine a lone body passing near a planet, or through the influence of a binary star system. Its path bends. Its fragments, if present, may be tugged, stretched, and shepherded into streams. Gravity does not always act with violence. Sometimes it acts with choreography, pulling particles into ribbons that drift behind the parent body. These streams are often the birthplaces of meteor showers on Earth, the reason we see predictable streaks of light in our skies each year. If swarms can be shaped within a solar system, why not between the stars? Perhaps Atlas wandered close to a heavy planet or star in another neighborhood long ago, its form fractured, its fragments arranged into a retinue that still follows. If so, what we see today may be only the distant echo of an ancient encounter. Dust clouds offer yet another explanation, subtle but no less compelling. When comets fragment, not all debris is large enough to stand as distinct companions. Much of it is ground into fine dust, a faint mist that can surround or trail the parent object. These clouds may scatter sunlight in ways that mimic discrete bodies, tricking telescopes into seeing companions where there may be only drifting haze. Astronomy is often an art of interpretation, piecing together meaning from faint and incomplete signals. A cluster of glimmers might be fragments, or it might be dust caught in the glare. To disentangle the two requires patience, data, and time. Luxuries not always available when an interstellar visitor speeds past, never to return. Mainstream astrophysics, cautious and disciplined, tends to reach for these explanations first. Fragmentation, gravitational shepherding, dust scattering. None require alien intentions. None demand extraordinary forces. They are familiar mechanisms, known to sculpt comets and asteroids throughout our own solar system. But familiarity does not make them dull. On the contrary, they are a reminder of the hidden drama that plays out among seemingly simple rocks and ice. Each fragment is a story of stress endured, of tides encountered, of collisions narrowly avoided. Each swarm is a living archive of forces both violent and subtle. And for scientists, the beauty lies in fitting the puzzle together. By studying how swarms form and behave, we glimpse the invisible threads of gravitational history. We can trace the encounters that shape them, and in turn, refine our understanding of how planetary systems evolve, scatter, and sometimes unravel. Still, the scientific explanations come with an unspoken caveat. While they are sufficient, they are not definitive. Observations are limited. Data is sparse. An interstellar object appears in our sky for mere weeks or months, and then it is gone forever, leaving behind only equations and speculation. The swarm around Atlas might be nothing more than the natural decay of a fragile traveler. Or it might be a cloud of debris sculpted by encounters long before it entered our sight. Or just perhaps, it might be something stranger still, a category not yet imagined. What science provides is a ladder, step after step, theory after theory, reaching toward the truth. But the ladder never quite touches the ceiling of certainty. In the spaces between the rungs, imagination seeps through. And so, while astrophysics teaches us to respect the ordinary, the cracks of comets, the pull of gravity, the shimmer of dust, it also teaches us humility. Nature often wears disguises, and what looks simple from afar may conceal a deeper complexity. The swarm around Atlas, whether mundane or profound, is a message written in fragments, a message still being decoded. And as scientists weigh natural explanations, another thought emerges. This is not the first time the sky has delivered riddles in the form of strange visitors. Echoes of the past linger, linking Atelius to Aumuai and to the broader tapestry of cosmic messengers that arrive unbidden from the dark. Long before telescopes, long before mathematics could chart the heavens, humans lifted their eyes to the sky and imagined. Every streak of light, every wandering star, every fiery visitor from above became a story, a warning, a sign. For in the stillness of ancient nights, the cosmos did not feel distant. It felt alive, watching, speaking. Among the Hopi people of North America, the night sky is not empty. It is inhabited by Kashinas, spiritual beings who travel between worlds, bringing guidance, lessons, or sometimes warnings. When strange lights appeared overhead, when comets blazed across the sky, they were not seen as accidents of rock and ice, but as messengers, cosmic travelers carrying meaning. In Vedic traditions, ancient Sanskrit texts speak of Vimanas, celestial chariots that crossed the firmament. Descriptions of luminous craft, engines of fire, and aerial battles blur the line between myth and observation. Were these metaphors, poetic visions of the divine? Or were they distant echoes of extraordinary skyward events? Comets splitting, meteor swarms falling like arrows of fire? Far across the Pacific, Polynesian navigators charted their world by the stars. To them, the heavens were not silent, but populated by deities and ancestors, travelers themselves. Myths tell of star gods who descended to guide canoes across the ocean, their brilliance etched into memory through constellations and stories. When meteors rained across the horizon, could they have been read as the return of these radiant guides, descending in a fiery swarm? Across cultures, across centuries, the pattern repeats. Sky visitors, messengers, beings of light or fire, sometimes benevolent, sometimes wrathful, always extraordinary. It is easy, from the vantage of science, to dismiss these as the poetry of early peoples, metaphors for forces not yet understood. Yet, there is a deeper possibility. What if myths are not inventions, but interpretations? What if they are records, imperfect, symbolic, but rooted in genuine encounters with the sky's unpredictability? Imagine an ancient community, far from the distractions of modern light and noise. The night sky is total, unbroken, commanding. One evening, a comet appears, brilliant, elongated, trailing a stream of fire. Days pass, and smaller lights begin to follow it, fragments shedding and scattering. To the modern mind, this would be a natural process. To the ancient mind, it could only be intention, companions, escorts, spirits following a leader across the heavens. This is the lens through which myths may refract truth. Swarms of fragments, meteor showers, cometary trains, natural phenomena transformed into story. Not fabricated, but mythologized. The cosmos speaks, and culture translates. Even the great philosophers of the ancient world pondered such things. Aristotle wrote of stars that shoot forth sparks, while Chinese astronomers meticulously cataloged guest stars and heavenly omens. In Mesoamerica, the Maya tracked Venus with astonishing precision, linking its movements to cycles of war and rebirth. To them, celestial visitors were never background. They were active participants in history itself. Comets, meteors, strange lights, they disrupted order. They demanded explanation. And so they became woven into the myths of travelers, of messengers, of gods. But here lies the haunting thought. If 3Ia Teleus, with its trailing swarm, had appeared 1,000 years ago, how would it have been described? Perhaps as a procession of sky spirits, or as a heavenly army crossing into our world. If it had appeared 10,000 years ago, painted across Paleolithic cave walls, might it have been remembered as gods descending from the stars? We see in myths not only imagination, but a reflection of the awe and fear our ancestors felt in the face of cosmic phenomena. The unknown pressed down on them more urgently than it does on us, and so they answered it with story. And yet, myth carries a strange resilience. Even as cultures change, stories persist. A comet becomes a dragon. A meteor swarm becomes an angelic host. A strange light becomes a divine chariot. The details shift, but the theme remains. The sky is visited. The sky is alive. Today, we might describe the swarm of fragments around Atlas in terms of astrophysics, orbital mechanics, sublimation, and debris fields. But is our language so different from theirs? They used gods in chariots. We use equations and simulations. Both are attempts to take the incomprehensible and render it into something the human mind can hold. Perhaps myth and science are not opposites, but echoes of the same impulse, to understand the travelers that arrive unbidden from the dark between stars. So when we read of the Hopi Kashinas descending from the heavens, or the luminous Vimanas streaking across the Vedic sky, or the star gods of Polynesia guiding voyagers across an ocean, we may pause. For behind the symbolism, there may lie an older truth, that humans have always lived beneath the watchful eye of the cosmos, and have always sought to interpret its sudden, unpredictable visitors. And just as myth transforms swarms of debris into gods, today we transform them into data points. The mystery remains, only the language changes. But if myths remind us that sky visitors are nothing new, science brings sharper tools. The fragments trailing Atlas may be explained through natural laws. Yet even as we analyze, one question lingers. Are we seeing the ordinary, or a new chapter in a much older pattern?
At dawn on June 30th, 1908, the quiet Siberian wilderness awoke to something extraordinary. the sky ignited. A searing flash lit the morning as if a second sun had risen over the taiga. Moments later, a shockwave thundered across the landscape, flattening trees for miles, shattering windows hundreds of kilometers away, and throwing people to the ground as though the earth itself had convulsed. In the remote region near the Podkamennaya Tunguska River, nature bore the scars. 80 million trees, scorched and leveled in a radial pattern, their trunks pointing away from a mysterious epicenter. Yet, when investigators arrived, they found something unsettling. No crater. No solid rock buried beneath the soil. Only devastation. For decades, the Tunguska event has remained a puzzle, a cataclysm without a culprit. The leading theory suggests a comet or asteroid, perhaps 50 to 60 meters wide, entered Earth's atmosphere and exploded mid-air with the force of 15 megatons of TNT, more powerful than the bomb dropped on Hiroshima. But if it was a comet, why here? Why then? And why no trace of the core? Some scientists argue that Tunguska was the work of a fragile body, one not made of iron or stone, but of ice and dust. A fragment that disintegrated completely in the atmosphere. Its blast would leave no crater, only fire in the sky and shock waves across the earth. Here, the mystery begins to echo the fears surrounding objects like 3I ATLAS. For if Atlas is not a lone wanderer, but a swarm, its companions may be just such fragile fragments, small enough to evade early detection, but large enough to release unimaginable energy if they strike. The Tunguska mystery is not only a story from the past, it is a reminder of what fragments can do. Witnesses in 1908 described bizarre phenomena. A fiery object streaking across the horizon, splitting the sky in two. The air itself seemed to burn. Nights across Europe were strangely bright for days afterward, as if the atmosphere had been seeded with a ghostly glow. People in London and Paris could read newspapers at midnight without a lamp. What caused this lingering light? Scientists believe dust and ice from the comet's disintegration spread high into the atmosphere, scattering sunlight across the globe. The event was local in destruction, yet global in its footprint. This duality, the sudden devastation of a wilderness, and the subtle transformation of skies thousands of miles away, reminds us how fragile and interconnected our planet truly is. A single fragment from the void can ripple across continents. Yet alternative theories persist. Some suggested a volcanic eruption, others a natural gas explosion from beneath the Earth. Fringe speculations even imagined alien spacecraft crashing into the taiga. None hold as much weight as the comet fragment hypothesis, but the persistence of mystery fuels imagination. Even now, more than a century later, Tunguska stands as a case study in cosmic vulnerability. It is the closest humanity has come in recorded history to experiencing an interstellar-like swarm impact. A reminder that the sky is not empty, that threats can come suddenly, invisibly, from above. Consider this: Tunguska occurred in one of the most remote regions on Earth. No major cities lay beneath its path. Had the same event taken place hours later, the blast might have struck St. Petersburg. Millions of lives could have been lost. History might have been rewritten. This thought lingers, that survival, in cosmic terms, may hinge not on preparation, but on luck. As we look at Atlas and its trailing companions, we must remember Tunguska. A fragment only tens of meters across was enough to devastate 2,000 square kilometers of forest. If even one body in the swarm of Atlas follows a similar fate, where might it fall? Over desert, over ocean, or over one of our great cities? This is the lesson hidden in the Tigger's silence. Cosmic disasters need not leave craters. Sometimes they leave only flattened trees, altered skies, and uneasy questions. The Tunguska mystery remains unsolved in its details, but in its essence it speaks clearly. Our planet has always been vulnerable. The cosmos has always been capable of surprise, and history is filled with whispers of what might happen again. Yet Tunguska is not alone. The history of the sky is written in fire and stone, in myths and in science. To understand the swarm following Atlas, we must not only look at modern telescopes, but also at the deeper record. The stories written across human memory and across the scars of Earth itself.
In the void between the stars, laws we take for granted on Earth begin to stretch and blur. Out there, gravity competes with radiation, light itself exerts pressure, and the unseen winds of plasma flow like invisible rivers. To understand why swarms might trail objects like 3I ATLAs, we must venture into this mysterious theater of forces, where physics writes stories stranger than myth. One of the first candidates is radiation pressure, the subtle push of light. Though photons have no mass, they carry momentum. When they strike the surface of dust grains or icy fragments, they impart a tiny shove. Alone, it is negligible. But across millions of particles over millions of miles, sunlight can sculpt great tails. And clouds, sweeping fragments into streamers that appear to follow their parent body. This is why comets, when they near the sun, grow glowing tails that always point away from our star, no matter which way the comet travels. It is not the comet itself that determines the tail's direction, but the constant, silent hand of light. Could a Tylese's companions, then, be no more than debris sculpted by this pressure, drifting in luminous trails behind it? A natural explanation, yet no less haunting. For what we see as beauty may in fact be a warning, fragments scattered, waiting for their own rendezvous with planets. Then there is the strange force of solar plasma, the solar wind. This constant stream of charged particles, racing outward at hundreds of kilometers per second, is invisible yet relentless. When it collides with a comet's coma, the halo of gas that sublimates from its icy body, it creates electrical interactions, magnetic tensions, and turbulence. These effects can fracture fragile surfaces, peel material into space, and create complex, shifting swarms of particles and fragments. Like a river battering a cliff, the solar wind erodes interstellar wanderers, leaving them trailing clouds that dance in ways not fully predictable. If 3I Atlas is shedding companions, the solar wind may be the sculptor, turning a single visitor into a procession of smaller shadows. But some researchers look deeper still, into the fabric of gravitational anomalies. Space is not empty. Invisible currents flow through it, carved by the mass of planets, moons, and the sun itself. When an object enters our system, it does not glide unperturbed. It is pulled, nudged, and sometimes torn by competing forces. Imagine 3I Atlas passing near Jupiter's reach, the giant as gravity acting like a cosmic hand, pulling on fragments with immense force. A body that might have traveled intact across light years could suddenly fracture, creating a trail of companions bound not by choice, but by circumstance. It is within these gravitational tides that swarms may be born. Not alien fleets, not mysterious intentions, but the simple consequence of physics. Rocks cracked by pressure, their pieces shepherded into loose, eerie formations. And yet, mysteries remain. Some interstellar objects, like Oumuamua, defied predictions. Oumuamua seemed to accelerate ever so slightly as it departed the sun, as though pushed by something unseen. No outgassing jets were observed, no obvious plume to explain the drift. It moved as if guided by an unknown hand. This possibility, that radiation pressure, plasma flows, or yet unmeasured forces could create behaviors we do not fully understand, lingers over every new object we encounter. So, what if 3I Atlas is not simply shedding fragments? What if the swarm is the result of subtler interactions? Radiation pressure shaping shards into formation, plasma winds shepherding them like a school of fish, or gravitational nudges arranging them into a pattern. Patterns that may look purposeful, but are not. Here, physics and perception blur. From the ground, through telescopes, we see trails, alignments, and groupings. Our human minds are wired to see intention in order. A flock of birds, a fleet of ships, a caravan of travelers. But in truth, these swarms may be nothing more than the dance of dust and rock caught between forces we cannot see. Still, there is an unease, for the physics that explains can also conceal. Just because something can be explained by natural forces does not mean it always should. And when behaviors fall too far outside expectation, the line between science and speculation grows thin. This is why 3I Atlas unsettles astronomers. Its companions may be fragments, sculpted by light, plasma, and gravity. Or they may represent interactions we have yet to map, clues to forces unaccounted for in our equations. The swarm, then, becomes more than a curiosity. It becomes a question mark. And perhaps that is the most haunting truth of all. For every step science takes in explaining these wanderers, new questions arise. Is light alone enough to explain their movements? Are gravitational tides too neat an answer? Could there be unknown forces, whispered across interstellar space, shaping their journeys in ways we have yet to imagine? The physics of the unknown is not only a field of study, it is an admission that in our age of satellites and observatories, of particle accelerators and quantum theory, there are still shadows in the laws of the universe. Shadows where swarms can hide. Perhaps Atlas is merely a fractured comet, its companions nothing but debris sculpted by familiar forces. Or perhaps it is a messenger not of what we already know, but of what we have not yet learned. But humans are not content with equations alone. Where physics ends, mythology often begins. And as long as the sky has held mysteries, cultures have woven them into stories of gods, of demons, of visitors from beyond. To understand the swarm of Atlas, we must turn next not only to science, but to myth. Since the first humans looked upward, the sky has been a canvas of both wonder and terror. Stars offered guidance, comets brought dread. To ancient eyes, a fiery visitor streaking across the heavens was no random event. It was a messenger, often of ruin. Across civilizations, myths speak of destroyers from the sky, not as isolated wanderers, but sometimes as swarms, harbingers that tore worlds apart or cleansed them in fire. The echoes of these stories may be no more than allegory. Yet what if they are more than metaphor? What if memory itself lingers in myth? In ancient Egypt, there was Sekhmet, the lion-headed goddess of war and plague. She was said to descend from the fiery eye of Ra, unleashed upon humanity when order faltered. Texts describe her fury as a scorching breath from the sky, leaving devastation in her wake. Some scholars see in this tale a cosmic parallel, the sudden arrival of blazing fragments, raining destruction like divine punishment. Was Sekhmet merely symbolic wrath? Or could her myth be the preserved memory of fire from above, a celestial event etched into culture as a deity of destruction? The Babylonians told of the 7 evil spirits, beings born of the sky, descending like a storm of burning coals. Ancient tablets describe them as a force that ravages the land, sweeping over cities like a flood. The number 7 is curious, not one, but many. Not a lone destroyer, but a host. Was this simply a poetic image? Or does it suggest a remembered swarm, fragments of a broken body scattering across the heavens, their approach read as omens of doom? Even in Norse mythology, we find whispers of celestial disaster. During Ragnarok, the twilight of the gods, the sky itself is torn apart. Stars vanish, the sun darkens, and fire giants march from the horizon, wielding flames that consume the world. A myth of cosmic destruction, yes, but perhaps also an echo of what a true swarm strike would look like. Darkness, fire, collapse, and the ending of an age. The Vedic texts of India speak of Vimanas, sky chariots of divine origin, some of them raining weapons of fire and light. The Mahabharata describes celestial battles where comets blazed like spears, leaving burning scars upon the earth. Was this simply mythic imagination? Or could ancient witnesses have seen showers of fiery fragments, their terror recast into the language of gods in wars? Further across the oceans, the Polynesian peoples carried tales of star gods who guided voyagers and punished the arrogant. In some stories, entire islands were said to vanish beneath fire and waves when the sky gods grew angry. Could this be an allegory for volcanic eruption? Or might it also carry a memory of the sea's rise after a cosmic strike, when fragments met ocean and sent tsunamis racing outward? The common thread is striking. Fire from the heavens, destruction by swarm, cycles of collapse and renewal. Skeptics will say these stories are only myth, archetypes of chaos and order, human fears clothed in celestial imagery. And indeed, myth is not history. It is not data. But myths are not created in a vacuum. They grow from seeds, events, experiences, patterns. And when so many cultures, separated by oceans and centuries, describe fiery intruders in the sky, we are left to wonder, what seed was planted across the world? Modern science tells us that impacts are real and devastating. Chicxulub ended the reign of the dinosaurs. Tunguska flattened the forest. Chelyabinsk shattered windows and shook nerves. If these events can happen in our age, why not in ages past? Perhaps myths of destroyers and swarms are not prophecies, but remembrances. The language of survival passed through story. And yet, the mystery remains. Are these myths coincidence? Or are they the human subconscious preserving a truth too vast to ignore? Could Sekhmet, the 7 evil spirits, the giants of Ragnarok, all be different faces of the same phenomenon, the swarm? As we look now at 3IA Tellus and its strange procession, we cannot help but feel a chill of recognition. For in myth, we see mirrors. In story, we glimpse memory. And when an object comes trailing companions through the solar system, the myths of destroyer comets no longer feel distant. They feel like a warning. But myths alone cannot guide us. To understand whether swarms are truly part of our cosmic reality, we must look to history's tangible scars, not carved in story, but etched into Earth itself. And perhaps the most haunting reminder is found in Siberia, where one morning in 1908, the sky fell without warning. We live in an age of eyes, eyes that do not blink, eyes that sweep the heavens, tirelessly searching. Modern astronomy has built a lattice of surveillance across the night sky, telescopes, satellites, and artificial intelligence systems scanning for intruders from the dark. Their purpose is both noble and urgent, to watch for what we cannot afford to miss. Among these watchful instruments, surveys like Pan-STARRS in Hawaii, Catalina Sky Survey in Arizona, and the upcoming Vera Rubin Observatory in Chile serve as guardians. They catalog asteroids and comets, updating maps of moving objects with each passing night. They are our planetary defense, the first line of awareness in a universe that is neither safe nor silent. It was within this net that 3I Atlas was caught, a faint moving point among countless stars. Algorithms compared images taken minutes apart, noting the subtle shift. A computer raised the flag. Human astronomers confirmed something new had entered our solar system, another interstellar visitor. But unlike its predecessors, Hellas came not alone. Trailing it, dim echoes appeared. First a single faint streak, then another. Were these imaging artifacts tricks of noise and distance? Or companions, fragments, an entourage? The surveys strained to tell the difference. Modern sky watchers are powerful, but not omniscient. Their vision is limited by weather, by daylight, by the clutter of satellites streaking across their fields of view. The Earth itself blocks half the heavens at any moment, and objects approaching from the glare of the sun remain hidden until they are dangerously close. In 2013, the world was reminded of this limitation. A rock only 20 meters wide entered Earth's atmosphere over Chelyabinsk, Russia. It arrived unseen, unnoticed. It was traveling in from the sunward direction, invisible to the surveys. The explosion injured over 1,000 people. And still, it was only a fragment, only a warning. So when we watch 3I Atlas and its curious swarm, we must remember, our surveillance is not perfect. If companions exist that are smaller, darker, or tumbling in unpredictable ways, they could slip through the net. They could be closer than we think. Artificial intelligence has become the silent partner of astronomy. Where once astronomers squinted over photographic plates, today neural networks scan millions of pixels in milliseconds. They learn to spot the faint motions, the subtle differences between background stars and true travelers. And yet, even I can be fooled. A faint satellite glint, a cosmic ray, the flicker of atmospheric noise, these masquerade as phantom objects, demanding human confirmation. The unsettling truth is that detection is always a race against invisibility. The universe does not make its threats obvious. Interstellar visitors move fast, dim, and strange. They do not behave like the well-mapped asteroids that circle our sun. They arrive from the deep, sometimes accelerating in ways we do not yet understand. And so astronomers wonder, what if we miss something? What if the swarm of Atlas is only partially seen, the true scale hidden by distance and faintness? What if some companions are already on divergent paths, untracked, unknown? Surveillance of the skies is not only about discovery. It is about reassurance. To look upward and believe we are aware of what approaches. But reassurance is fragile. One missed object, one sudden fireball over a city, is enough to remind us of how thin the net really is. Astronomers often describe the sky as a kind of ocean, and themselves as sailors charting its currents. Each new interstellar object is a message in a bottle, evidence of other shores beyond sight. But when those messages come in swarms, the metaphor shifts. The ocean becomes stormy, and the question is no longer whether we are being watched, but whether we are watching enough. Still, there is awe in this vigilance. The fact that from a small planet we can track visitors from the stars at all is extraordinary. It speaks to the reach of human curiosity, the determination to make the unknown known. Yet awe is paired with unease. For the more we see, the more we realize how much remains unseen. 3.1 Aleus has become a test, not only of theories, but of our surveillance itself. Each companion glimpsed or lost in noise is a measure of our readiness. Each unanswered question about its swarm reminds us knowledge is never complete. And so we arrive at the unsettling thought: what if our eyes deceive us? What if the most important fragment is one we fail to notice until its shadow falls across our own world? The watchers of the sky can only look. They cannot prevent. And sometimes, even the act of looking may not be enough. To understand what happens when fragments slip past our guard, we must look not to the future, but to the past, to moments when the sky itself betrayed us. The scars of those encounters remain etched into Earth's story. Some are well known, others still mysterious. One of them lies in Siberia in the summer of 1908. High above our world, beyond the reach of storms and sound, an object is said to drift in silence. It is called the Black Knight satellite, a name that feels both ancient and futuristic, both myth and machine. The legend claims it has been orbiting Earth for thousands of years, a relic of a civilization unknown, or a sentinel from the stars. A story born in fragments, like the faint companions of 3I Atlas itself. The tale begins not with discovery, but with whispers. In the late 19th century, Nikola Tesla, experimenting with wireless transmissions, reported receiving signals that seemed unnatural, rhythmic, repeating. To him, they might have been communications from another world. To later generations, those mysterious signals would be tied to the Black Knight myth. Decades later, in the 1950s, military radars picked up echoes in orbit that did not match any known satellite. These long-delayed echoes, as they were called, added to the mystery. And then, in 1960, a U.S. Navy radar reportedly detected a large, dark object in polar orbit, something unusual, for at that time, neither America nor the Soviet Union had placed satellites in such a path. The press seized on the rumor. Was there something alien circling us already? The myth grew. In the 1990s, photographs taken by the Space Shuttle Endeavour during a mission to the International Space Station seemed to show a strange, angular object, twisted, almost sculptural, as though designed with purpose. To some, this was the Black Knight itself, finally caught in human sight. NASA would later explain it as thermal insulation that had broken free, a mere scrap of human technology adrift. But for those inclined toward mystery, the explanation was too neat, too easy. Why does the legend persist? Perhaps because it touches something primal, the fear that we are being watched silently from above, the idea that the heavens are not empty, but occupied. The Black Knight is not confirmed. It may never have existed as anything more than radar noise, photographic illusion, or the dreams of men like Tesla. And yet, the myth resonates because it parallels something very real, the unsettling possibility of objects beyond our control, drifting where we cannot always see them. And now, as we watch 3I Elias entering our solar system, with a swarm of companions trailing in its wake, the echoes of the Black Knight return. What if Atlas itself is not merely rock and ice? What if, hidden among its companions, something watches? Something that has always watched. The parallel is almost poetic. The Black Knight is said to orbit Earth eternally, an unseen guardian or a silent threat. The Atlas swarm arrives from the void, unannounced, unexplained. Both legends thrive in the space between certainty and speculation, where science leaves gaps for imagination to enter. Perhaps the Black Knight was nothing more than debris, but perhaps it was something else, a fragment of memory disguised as myth. In the same way, the swarm trailing Atlas could be simple debris, cometary fragments no different than countless others. Or, in the darker corners of thought, they might be deliberate, scouts, sentinels, or machines disguised as stone. Every civilization tells itself stories of watchers in the sky. For the ancients, they were gods or spirits. For us, they take the form of satellites, probes, and swarms. The difference is only in language, not in essence. The sky is never empty. It is filled with presence, with mystery, with the suggestion that we are not alone. And this is why the black night endures. Because deep down, we expect the unknown to be watching us. We expect the universe to notice. Imagine for a moment if the black night were real. A satellite of alien design, placed in polar orbit centuries ago, quietly observing humanity's rise from caves to cities, from stone tools to rockets, watching and waiting, never interfering, never revealing, just circling. Would its purpose be benevolent? A beacon guiding us into the greater cosmic community? Or would it be something colder, surveillance, assessment, perhaps even judgment? To those who believe, the black night is not only a relic, it is a mirror reflecting our own unease about being seen. And so the connection to Atlas feels natural. A visitor not alone, but accompanied by a swarm. Fragments or companions? Debris or design? The question lingers, just as it does with the dark satellite said to haunt Earth's orbit. Skeptics remind us, myths like the Black Knight flourish because of coincidence. Tesla's signals were likely natural radio waves. The Navy radar echoes may have been tracking errors. The space shuttle photographs were almost certainly insulation. There is no confirmed object, no verified machine circling our world. But myths persist not because they are true, but because they speak to truths we feel but cannot prove. The truth that the universe is vast and uncharted. The truth that we are small and vulnerable. And the truth that we do not fully trust the silence above us. The Black Knight satellite is not fact, but it is a symbol, a reminder of how easily mystery seeps into the cracks of knowledge. Just as Atlas and its swarm now seep into our imagination. What if this is not merely nature at work? What if the pattern we see is intentional? The question is unanswerable. But in the act of asking, we reveal something about ourselves. Our hunger for connection, our fear of surveillance, our longing to be part of a story greater than our own. From myths of orbiting watchers to the undeniable scars carved into our own planet, the question shifts. If objects like Atlas and its swarm, or legends like the Black Knight, have always been part of our cosmic story, and what traces have they left behind on Earth itself? For that, we must look back to one of the strangest explosions in human memory, the Tunguska event. Our planet spins in quiet majesty, a fragile blue oasis in the vast, indifferent darkness. From the comfort of its atmosphere, Earth feels eternal, solid, and enduring. Yet beneath this illusion lies a startling truth. Earth is vulnerable. The very forces that shaped its mountains and carved its oceans can, without warning, rewrite the story of life itself. Over the course of deep time, the Earth has been struck by visitors from the void. Some were small, harmless, others colossal. The Chicxulub impactor, 66 million years ago, ended the age of the dinosaurs. Its collision released energy beyond human imagination, igniting forests, triggering tsunamis, and casting clouds of dust that dimmed the sun. Entire ecosystems collapsed. Life survived, but only because it adapted to a world transformed in ours. Smaller impacts are far more common than giant ones. Tunguska in 1908 flattened 80 million trees. Chelyabinsk in 2013 shattered glass and shook cities, warning us that even minor fragments carry real consequences. Every day, Earth is bombarded with meteoroids. Most burn away harmlessly in the atmosphere, invisible to the human eye. But the rare fragment that does not is a reminder of how thin our protection really is. Consider this: a swarm trailing 3I Atlas. Individually, each fragment may be small, perhaps no larger than a house, perhaps ice and rock, easily disintegrating in the atmosphere. Yet even fragments of modest size can trigger chain reactions. Fires can spread, electrical grids can fail, communication networks can collapse. Human civilization is tightly interwoven, dependent on stability in climate, energy, and food. A small celestial nudge can ripple outward, amplified by our own fragility. And the Earth's fragility is not limited to immediate destruction. Impacts can accelerate existing crises. A swarm could loft dust into the stratosphere, blocking sunlight. Crops could fail. Volcanic activity might awaken in unstable regions, triggered by subtle shifts in stress along tectonic plates. The atmosphere, oceans, and human systems are connected. A strike in one corner of the world can resonate everywhere. It is a sobering thought. Nature does not need to be deliberate. The cosmos is indifferent. We tend to imagine disasters in isolation, a single comet, a rare asteroid. But swarms are different. They are multiplicative. A single object may glance by, leaving only intrigue. But a trail of companions, arriving over days or weeks, is a cascade of opportunity for destruction. Ancient civilizations may have witnessed such events. Stories of fire from the sky, of floods and plagues, could be echoes of small-scale impacts, of swarms passing unnoticed, leaving behind scars in oral memory. Perhaps the myths of Sekhmet, the seven evil spirits, or the fire gods of Polynesia are not purely symbolic, but a distorted record of the fragility humans have always faced. Even now, our planet carries scars from impacts past, craters across continents, layers of shocked rock, spherules scattered like cosmic breadcrumbs. They remind us that no landscape, no civilization is immune. We inhabit the thin surface of a planet whose equilibrium is delicate, a skin stretched across deep oceans and molten cores, susceptible to forces beyond our imagination. And the fragility extends beyond the physical. Consider our global systems: food production, energy grids, water networks. These are marvels of organization, but they are finely balanced. Disrupt one link, and the chain can falter. A swarm of fragments striking in populated regions or key agricultural zones could cascade into famine, economic collapse, and political instability. Civilization itself is a tightrope, and even minor cosmic disturbances can push it toward the edge. Yet there is paradoxical beauty in this vulnerability. Our fragility drives ingenuity. Humanity builds satellites to track asteroids. We develop impact deflection technologies. We model climate systems and strengthen global communication. Awareness of fragility is not despair. It is the seed of resilience. But awareness also carries a weight, the acknowledgement that despite our technology, despite our observation, the universe can still surprise us. In the case of 3I Atlas and its companions, we are reminded that the unseen is always possible. A swarm may pass unnoticed, fragments may evade detection, the sky may deliver the unexpected. Earth, for all its beauty and complexity, remains exposed to the vast reaches of space. The fragility of Earth is not a theoretical abstraction. It is etched into rocks, whispered in myths, felt in shocks, and glimpsed in every near miss. Every fragment, every swarm, every anomaly in the heavens is a reminder that life is temporary, delicate, and interdependent. And perhaps this is the lesson of the cosmos. Survival is not certainty, it is adaptation, it is humility. We walk upon a planet that spins amid invisible hazards, watched by forces that care nothing for human ambition or fear. Yet Earth's fragility is only one side of the story. For every risk, there is response. Humanity has begun to imagine not just survival, but intervention. To anticipate the swarms, to track them, and to act before the sky itself acts. And it is to these emerging strategies that we now turn. The universe is vast, infinitely vast. Stars, planets, and clouds of gas stretch beyond what the mind can fully grasp. And yet, when we look up, a question emerges. Where is everyone? The night sky is alive with light, yet silent with absence. This is the essence of Fermi's paradox, the puzzle that has haunted astronomers, philosophers, and dreamers for decades. If the cosmos is so old, And if planets abound, why do we see no evidence of intelligent life? Where are the civilizations that might have risen, flourished, and looked up at their own skies as we look at ours? One theory proposed to explain this silence is the Great Filter. Somewhere between the formation of life and the emergence of advanced civilizations, there exists a barrier, a set of challenges so immense, so catastrophic, that most life never passes it. Perhaps most worlds collapse under their own technology. Perhaps resources run out. Or perhaps the universe itself is a hazard, a gauntlet of cosmic threats waiting to test every fragile intelligence. It is here that the story of interstellar swarms intersects with the Great Filter. Could swarms like that trailing 3 Ia Olayed represent one of the universe's silent tests? Rocks and ice, traveling for millions of years, indifferent to life, passing through star systems, leaving destruction in their wake. A cosmic sieve through which most civilizations cannot survive. Consider Earth itself. In the deep past, we were threatened by impacts we barely understand. Massive asteroids reshaped ecosystems. Swarms of smaller fragments could have been even more insidious, repeatedly striking, destabilizing climate, wiping out fledgling species. For every civilization that survives, countless others may have fallen quietly, their signals erased before they had the chance to reach the stars. Perhaps this is the filter. Not a single, cataclysmic blow, but a universe littered with fragments and hazards, testing the resilience of life over eons. Each planet must endure impacts, survive environmental fluctuations, and adapt to crises. Few may pass. And the rare survivors, like humanity, emerge only by a combination of chance, intelligence, and sheer perseverance. Some scientists have speculated further. Interstellar objects could be one of many universal checks, natural barriers that prevent life from advancing too far, too quickly. Swarms, because they arrive without warning and in multiplicity, could overwhelm planets before defenses evolve. They are impartial. They care nothing for culture, technology, or morality. To them, life is insignificant. And yet, in surviving these trials, civilizations learn. They innovate, they cooperate, they watch the skies. Could it be that the very absence of alien visitors is proof of the filter? That somewhere in countless star systems, life tried to rise, only to be extinguished by cosmic hazards, by swarms of debris, by impacts too subtle to detect from light years away? And now, as 3I Atlas approaches, with companions trailing silently behind, we are reminded that the universe has always been patient in its testing. Fermi's paradox forces reflection not only on alien life, but on ourselves. If swarms can act as a filter, we may be living in a rare window of opportunity. The same object that inspires awe, a visitor from another star, is also a mirror. It reminds us of how close we are to the edge, how fragile our survival might truly be. And it asks us, what will we do with this awareness? Could human technology be enough to navigate this cosmic gauntlet? Can we detect swarms before they strike? Can we deflect or mitigate their danger? Or are we merely learning, too late, what countless civilizations before us have failed to learn? There is a quiet terror in this perspective. It is not monsters or malevolence that threatens civilizations across the cosmos, but impartial physics, swarms, impacts, environmental chaos. Civilizations may flourish briefly, only to be extinguished by circumstances they cannot control, leaving no trace except empty worlds and the faintest whispers in the dust of space. Yet, paradoxically, the Great Filter also inspires hope. For if humanity endures, if we learn to anticipate and survive, we may be among the rare successes. We may be observers not only of the cosmos, but of its tests, witnesses to the universal struggle for survival. Perhaps by tracking Atlas and its companions, by understanding their physics and predicting their paths, we take our first steps in transcending the filter. The concept is sobering. Each object in a swarm is not merely rock, ice, or debris. Each is a potential trial, a cosmic question posed to every intelligent species. Will you survive? Will you adapt? Will you persist? And when we look up at Atlas, trailing its procession of companions, we see not just a celestial spectacle, but a living lesson in the universe's quiet impartiality. Perhaps the great filter is behind us, perhaps ahead. Perhaps it is always present, in swarms that drift through every solar system in the silent rhythm of cosmic hazards. The question lingers. How many civilizations never make it past the test? How many planets have borne life only to have it erased before it could look beyond its own sky? Transition. And yet, even as the filter looms, the story does not end in despair. Awareness is the first step toward survival. Having glimpsed the potential trials, humanity can act, innovate, and prepare. From the silence of the stars, we learn not only our vulnerability, but our capacity. The next chapter will explore how we might respond, how we might shape our destiny in the face of the universe's unyielding tests. Long before telescopes and satellites, humans looked to the sky with awe and fear. Every flare of light, every streak across the heavens was recorded in myth, song, and ritual. These were more than stories. They were warnings, coded in imagery, designed to teach, to caution, to survive. Across continents and eras, we find echoes of a shared understanding. The sky is not always a benign canvas. It can bring prosperity, but it can also bring destruction. In these myths lie veiled lessons, perhaps hints that ancient peoples recognized patterns we are only now beginning to understand. In Norse mythology, the story of Ragnarok tells of a twilight of the gods, when fire giants march across the horizon and the heavens themselves are torn asunder. The sun and moon darken, stars vanish, and the world trembles before rebirth. While we read it as allegory, perhaps it is also a memory of celestial catastrophes, repeated strikes, swarms of objects moving through the sky, their impact recorded as fire, chaos, and apocalypse. The Norse did not speak of single events. They spoke of cycles, of recurring destruction and renewal. Could this hint at the possibility that swarms are not isolated phenomena, but patterns that repeat over centuries or millennia? That cosmic intruders, like three-eye Atales and its companions, arrive in waves, testing the resilience of civilizations? Across the oceans, the Hopi people of North America speak of the purification, a time when the world is cleansed by fire and catastrophe. Their prophecies describe sky beings or stars that fall like rain, reshaping the earth and challenging humanity. The imagery is vivid, frightening, and precise. And like Ragnarok, it is cyclical, a warning repeated through generations. These are not idle stories. They carry behavioral instructions. Respect the sky, observe its patterns, remember the fragility of life. Could the purification be a symbolic record of swarm events? Perhaps ancestors witnessed meteors, comets, or smaller fragment showers, embedding the memory in ritual and oral tradition. In Hindu cosmology, time is not linear, but cyclical, divided into yugas, ages that end with destruction and renewal. Each cycle culminates in pralaya, a cosmic dissolution that can take the form of fire, water, or both. Descriptions of the heavens raining devastation, of celestial forces reshaping the planet, resonate with the same cautionary tone found in Norse and Hopi traditions. Across all these cultures, the repeated theme is striking. The sky itself can punish, can test, and can reshape life. The recurrence of these myths suggests a long memory, perhaps one of encounters with cosmic swarms, events that were rare enough to be remembered as extraordinary, yet common enough to form a pattern. It is tempting to dismiss these myths as mere allegory. Fire giants, falling stars, purifications of the world, they belong to imagination. Yet when we compare these stories to the science of interstellar objects, patterns emerge. Swarms of fragments, moving unpredictably, can deliver repeated shocks to a planet. Dust and debris can trigger climate shifts. Impacts can alter ecosystems. The ancients may have sensed these risks and encoded them into narrative form, leaving us with stories that are cautionary and cyclical, rather than linear and explanatory. Ancient warnings also reflect an understanding of scale and inevitability. They acknowledge human helplessness in the face of cosmic forces. The Norse gods die in their own twilight. The Hopi speak of fire that cannot be stopped. The Hindu texts describe pralayas that consume all. These myths recognize that while humans may influence their world, the sky remains beyond full control. There is a lesson here for the present. As we track 3I Atlas and its trailing companions, we are engaging in a modern interpretation of the same ancient vigilance. The myths remind us, observation is not enough. Preparation is vital. Knowledge is necessary, but it must be coupled with action. And yet the myths offer hope as well as warning. After Ragnarok, the world is renewed. After the purification, life continues. After the Yugas, creation begins anew. Cycles of destruction are also cycles of opportunity. These stories are not just about fear, they are about resilience. They teach us to expect the unexpected, to endure, and to learn from every encounter with the cosmos. The ancient warnings and the modern surveillance of celestial visitors converge in a startling thought. Perhaps humanity is only now beginning to decode the lessons that past civilizations encoded in myth. The swarms we track, the fragments we measure, the unknown companions trailing interstellar travelers, they are not only scientific curiosities. They are echoes of the same celestial forces that inspired awe and caution across millennia. In this light, myths are more than stories. They are a repository of experience, a record of vulnerability, a call to vigilance. And they challenge us to consider the possibilities that lie beyond observation, the objects we cannot yet see, the swarms we have not yet detected, the forces that test our fragility and ingenuity alike. From the encoded warnings of ancient myth, we move into the tangible reality of survival. The stories of gods and fire are mirrors of the same questions that science now asks. How do we prepare? How do we respond? And when the next swarm comes, whether it is Atlas or something else, will we heed the lessons embedded in both myth and observation? We often assume that the cosmos is indifferent, that comets drift, asteroids tumble, and interstellar objects are no more purposeful than dust in the wind. But sometimes, patterns emerge that defy the simple elegance of physics. Trails of objects moving in tandem, accelerating unexpectedly, or appearing where calculations say they should not. These anomalies invite speculation. And in the case of 3I-ATLAS, some scientists and theorists wonder, could this swarm be directed? The idea is both thrilling and unsettling. Imagine a procession of objects traveling across the solar system, not by chance, but by design. Not as random debris, but as orchestrated elements, probes, machines, or autonomous constructs sent to observe, test, or even interact with the worlds they encounter. Among speculative scientists, one term surfaces often: von Neumann machines. Self-replicating probes, capable of exploring galaxies autonomously, multiplying by harvesting resources as they go. A swarm trailing an interstellar object could, theoretically, serve as reconnaissance, a cosmic scout system, examining planets and leaving traces long before intelligence arrives. The universe, in this scenario, is not silent. It is quietly probing, learning, and cataloging life across the stars. Alternative theories suggest even more ancient possibilities. Could fragments like Atlas be remnants of civilizations long vanished? Broken spacecraft or deliberately launched artifacts, wandering the galaxy for eons? If so, the swarms we detect might not be entirely natural. They might be guided by mechanisms we do not yet recognize. Perhaps the gaps in their trajectories, the subtle accelerations, are signals, deliberate adjustments to navigate past gravitational fields, to remain undetected until they reach a target. The Black Knight satellite, the tailies of Oumuamua, and now Atlas trailing companions, all converge under this lens. Could there be a lineage of cosmic observers, machines set in motion hundreds of thousands of years ago, moving slowly but persistently through the galaxy, watching, recording, or even influencing the evolution of life? Of course, these ideas challenge the foundations of mainstream science. Gravity, inertia, radiation pressure, these explain much of what we see. Natural fragmentation, collisions, and cometary dust clouds are far simpler explanations. Yet anomalies persist. Oumuamua's unusual acceleration, the clustered companions of Atlas, the fine-tuned trajectories, each invites curiosity. We are left with a spectrum of possibility, from the entirely natural to the utterly intentional. Could the universe itself host silent engineers? Could intelligence be seeding the galaxy in ways invisible to us, leaving fragments and swarms as breadcrumbs for later civilizations to find? The notion is disquieting, yet elegant. It reframes randomness as purpose, chaos as pattern, and silence as observation. If swarms are directed, their purpose is unknowable. Are they hostile, curious, indifferent? We are reminded of the prime directive in science fiction. Advanced civilizations may choose to observe rather than interfere. A directed swarm could simply record, measure, and catalog, leaving no overt trace until long after the observed world has learned to survive or perish. And yet, even without intent to harm, the effect could be catastrophic. Swarms that collide, fragment, or miscalculate trajectories can trigger local disasters. A machine designed to observe might still produce collateral damage. The line between intentionality and accident is blurred when dealing with forces that dwarf our understanding. History may contain echoes of such encounters. Many myths describe objects falling from the sky, sometimes in clusters. Could these be distant memories of past swarms, natural or directed, brushing past ancient civilizations? Stories of fire raining from heaven, of destructive sky serpents, or celestial purifications may encode long-forgotten observations of swarms that were unusual enough to inspire fear and ritual. Perhaps these are not mere coincidence. Perhaps the galaxy is filled with relics of purposeful movement, slowly drifting toward the planets that are ready to host life. And now, Atlas and its companions offer the first clear glimpse of such a procession entering our own solar system. Speculation of this magnitude invites both excitement and fear. It challenges our assumptions about intelligence, about the universe, and about humanity's place within it. If swarms can be directed, we are not simply observers of the cosmos. We may be participants in a larger experiment, or at least a silent audience to the movements of something far older and more patient than ourselves. It also reframes the stakes of observation. Tracking Atlas is no longer a matter of planetary defense alone. It becomes an exercise in understanding the unknown, a practice in interpreting subtle signs and anomalies. Every fragment we detect, every deviation we measure, is a clue, perhaps to natural processes, perhaps to intentions beyond comprehension. And so we face a dual reality. The swarm may be just rock, ice, and cosmic debris, or it may be evidence of something profoundly different. A network, a sequence, a probe-like consciousness reaching through space and time. The uncertainty itself is a lesson, reminding us that curiosity and caution must coexist. As we continue to watch, analyze, and speculate, we are participating in a story that spans millennia and light years. The arrival of Atlas and its companions is not just an astronomical event. It is a prompt to ask questions about intelligence, purpose, and our fragile role in a galaxy filled with mysteries we are only beginning to perceive. Transition. From speculation on directed swarms, we turn now to the science that underpins the movement of such objects. What laws govern their trajectories? And how might physics itself reveal whether Atlas and its companions are natural, artificial, or somewhere in between? The answers may lie in the very mechanics of the universe, written in motion across the sky. It was a night like any other in August of 1977 when astronomers at Ohio State University turned their radio telescope toward the heavens. Their instrument, the Big Ear, was scanning the vast silence for whispers of the cosmos. And then it happened. A signal appeared, brief, intense, and unlike anything they had encountered. On the printout, someone wrote in awe, "Wow!" The signal lasted just 72 seconds, but it has echoed across decades, a tantalizing hint that the universe might be speaking, or at least attempting to. Despite countless follow-up observations, the source was never confirmed. No natural explanation fit the pattern. No repeat signal emerged. And so it became the most famous unexplained radio burst in human history. The wow signal. For many, the signal was a curiosity, an anomaly, a statistical fluke. For others, it was a hint of something far greater, a deliberate message, a probe reaching out across light years. The question lingers, could the signal have originated from a swarm of interstellar objects like Atlas and its companions? Could they serve not just as celestial hazards or cosmic wanderers, but as carriers of information, subtle messengers encoded in radio, reflection, or trajectory? Consider the nature of the signal. Narrow, focused, precise. It was a spike against the quiet background of space, a momentary heartbeat in the cosmic darkness. Much like the clustered companions trailing Atlas, it appeared anomalous, structured, and yet fleeting. Perhaps some speculate such bursts are the universe's way of marking its presence, reminders that the void is not entirely empty, that intelligence or intention might lurk within seemingly natural phenomena. The wow signal invites reflection on the limits of our perception. For 72 seconds, it pierced the ordinary background noise of the universe. For a brief moment, humanity glimpsed the possibility that we are not alone, that messages can travel across light years, that swarms or probes might communicate in ways subtle enough to escape casual detection. Some theorists suggest that interstellar swarms could carry such signals as a natural byproduct of their movement or as deliberate transmission. Perhaps fragments trailing a primary object create interactions with stellar radiation or cosmic fields, producing bursts that are detectable only under rare conditions. Or perhaps, as some more speculative minds propose, intelligence is embedded within the swarm itself, orchestrating communication in ways we have yet to decode. And yet, the universe remains indifferent. The wow signal did not repeat. No reply was sent. No obvious consequence followed. It exists only in memory and printouts, in the curiosity it sparked and the questions it left unanswered. It reminds us of the fragility of observation, of how easily we can miss the messages scattered across the cosmos. Messages that might arrive in the form of radio waves, in the arcs of orbiting objects, or in the subtle clustering of fragments trailing an interstellar visitor. Perhaps the signal is natural, a quirk of hydrogen emissions or cosmic noise. Perhaps it was a glimpse of something extraordinary, a hint that swarms of interstellar objects traveling across the void carry more than mass. They carry information, like breadcrumbs along a trail, waiting for a species capable of noticing. There is poetry in this thought. A silent object drifting for millennia, accompanied by smaller fragments, passing through star systems with quiet precision. And somewhere along its journey, it produces a signal, brief, fleeting, ephemeral, enough to ignite wonder in a curious civilization. The wow signal is a reminder that the universe has layers, and that what we see, what we measure, is only a fraction of the whole. It also underscores the patience of cosmic processes. Swarms may move slowly, imperceptibly, yet their presence is persistent. Signals may come once or 1,000 times, but detection depends on attention, alignment, and perhaps luck. Humanity happened to be listening in that precise window in 1977, and for that, the moment became immortal. The story of the wow. Signal parallels the mystery of 3I, A, Tau, A, as both appear as anomalies within otherwise predictable cosmic patterns. Both challenge our understanding of what is natural and what may be deliberate. Both invite us to look closer, to wonder about the intelligence and structure hidden within seemingly random motion. And both remind us that the universe can communicate in ways subtle, fleeting, and profoundly impactful. As we continue to track Atlas and its trailing companions, we may someday detect another wow-like event. Perhaps a fragment will reflect radio waves unusually, or produce a pulse across a spectrum we are only beginning to monitor. Perhaps intelligence, embedded or emergent, is leaving breadcrumbs along its path, waiting for a civilization like ours to notice. Until then, the wow signal remains a testament to curiosity, a reminder that even the faintest anomaly can alter our understanding of the cosmos. It is a whisper from the stars, brief but unforgettable, connecting our imagination to the vast and often silent expanse of space. From the fleeting heartbeat of the wow signal, we turn to the broader implications for Earth itself. If swarms can carry information, they can also carry energy, mass, and danger. Understanding their paths is not just an academic exercise, it is a measure of our own survival. The fragility of our world becomes clearer when we imagine the consequences of these cosmic visitors. The sky above seems serene, a canvas of deep blue or star-speckled black, yet it hides a force capable of reshaping the world in an instant. Even fragments that appear insignificant, mere rocks or ice traveling across the void, carry energy unimaginable. When swarms of such fragments enter a planet's atmosphere, the consequences can ripple far beyond the immediate impact. History and science converge to illustrate the stakes. The Chicxulub impact, 66 million years ago, created not just an extinction event, but a chain reaction, massive fires, atmospheric dust that blocked sunlight, and global cooling that lasted decades. Smaller fragments, arriving in clusters, can produce localized destruction that multiplies in effect. Firestorms ignite, forests vanish, and soot fills the skies, triggering temperature drops that ripple through ecosystems. Even modest fragments can have outsized effects if they strike in sensitive regions. Agricultural heartlands, densely populated cities, or tectonically active zones amplify the consequences of every strike. A swarm is not merely multiple impacts, it is cascading chaos, a domino effect of disruption that could stress every human and natural system simultaneously. Volcanic activity is particularly vulnerable to such triggers. Shockwaves from impacts can awaken dormant magma chambers, forcing eruptions that add to the atmosphere's burden of dust and aerosols. The combination of solar dimming, firestorms, and volcanic emissions can create what scientists call a volcanic winter, a period of prolonged cooling, crop failures, and ecological stress. Such phenomena are rare, yet history offers hints. The Younger Dryas, a sudden cooling episode 12,000 years ago, may have been triggered by extraterrestrial impacts, although the evidence is still debated. The climate response to a swarm is not linear. Small fragments, separated by days or weeks, could trigger successive mini-catastrophes, each one reinforcing the last. The planet's system's atmosphere, oceans, and biosphere are delicately balanced. Disturb one element, and the rest may follow, like ripples across a frozen pond. Fire is another vector of chaos. Impacting fragments ignite forests and cities alike. Smoke and soot enter the stratosphere, dimming sunlight, altering weather patterns, and reducing photosynthesis. Crops fail. Ecosystems falter. Even species adapted to sudden environmental stress may succumb if the impacts continue in rapid succession. A single fragment can be devastating, but a swarm is a festival of fire, a series of explosions and infernos that strain the resilience of life. In mythology and lore, such events are recorded as divine punishment or cosmic purification. Norse accounts of Ragnarok, with skies filled with fire and ash, resonate eerily with what modern science describes as cascading climate catastrophes. Hindu texts describe pralayas, cosmic dissolutions that resemble the aftermath of repeated impacts. Across cultures, the sky's fury has been remembered not just as metaphor, but as warning, perhaps even as reflection of real past events. Climate systems are complex, interconnected, and nonlinear. Minor changes can amplify through feedback loops. Volcanic eruptions darken the sky, leading to colder temperatures, which reduce agricultural output, causing famine. Wildfires triggered by impacts release greenhouse gases, further destabilizing climate. Swarms introduce chaotic input into these systems, unpredictable, sequential, and globally consequential. Even a modest celestial cluster, striking sparsely but persistently, could generate global consequences beyond immediate understanding. The human dimension is equally fragile. Modern civilization depends on stable weather for agriculture, energy production, and water management. Cascading impacts could challenge every infrastructure we take for granted. Short-term disruptions might escalate into long-term crises. Famine, social unrest, and even collapse of governance in regions hit hardest. The chaos of climate change would be amplified by cosmic triggers, creating a hybrid of natural and anthropogenic vulnerability. Yet the potential for understanding and mitigation exists. Models can simulate the effects of clustered impacts on climate systems, predicting temperature drops, atmospheric circulation changes, and ecological outcomes. Satellites track asteroid trajectories, and planetary defense strategies aim to deflect objects before they reach critical thresholds. But swarms are more difficult to predict than solitary impactors. Their multiplicity and irregularity challenge our best models, reminding us that the universe is patient and indifferent, and that preparation requires foresight, technology, and humility. There is also a psychological dimension to consider. Awareness of potential swarms and climate chaos changes the human perspective. It forces recognition of our vulnerability, not just to one catastrophic event, but to sequences of events beyond our control. It emphasizes resilience in infrastructure, in society, and in mindset. Every advance in detection, every improvement in disaster preparedness becomes a small hedge against the randomness of cosmic delivery. The narrative of climate and chaos is thus twofold: terrifying and enlightening. It reminds us that Earth's systems, though seemingly stable, are finely tuned, sensitive to shocks both terrestrial and extraterrestrial. Yet it also illustrates the power of observation, analysis, and anticipation. Humanity can act to understand, to prepare, and to adapt, even in the face of swarms that drift silently across the void. From the chaos of climate and cascading destruction, our journey turns to history and memory. Could past civilizations have experienced similar trials? Could myths and lost cultures encode warnings about swarms and the climate consequences of their passage? The answers may be hidden in the echoes of the past, waiting for us to uncover them. Across the sands of time, stories whisper of civilizations that rose, flourished, and vanished sometimes without a trace. Atlantis, described by Plato as a powerful and advanced society, was said to be swallowed by the sea in a single day and night. The Younger Dryas, a sudden climatic cooling some 12,000 years ago, saw massive ecological upheaval. And scattered across history are legends of cities lost to floods, fires, or inexplicable disasters. Could there be a thread connecting these tales? A force both natural and cosmic, shaping the fate of civilizations before they could leave a lasting mark? Interstellar swarms, drifting silently across the void, offer one unsettling possibility. Consider Atlantis. Plato's account is vivid: towering cities, canals, and knowledge lost beneath rising waters. While many dismiss the story as allegory, some archaeologists and geologists note that sudden flooding events have occurred in Earth's history: coastal submersions, tsunamis, and rapid climate shifts. Could a fragment of a swarm, impacting oceans or triggering seismic shifts, have produced the catastrophic flooding Plato described in allegorical form? Perhaps the myth encodes a memory of a swarm-related event, preserved and transformed through oral tradition into moral and political narrative. The Younger Dryas period presents a more scientific case. Evidence suggests a sudden influx of cold air, massive wildfires, and ecological stress that disrupted early human societies. Some researchers propose that extraterrestrial impacts, possibly fragments from a single large comet or a swarm, contributed to these rapid environmental changes. Layers of soot, unusual meteorites, and melt glass deposits in sediment hint at high-energy events impacts that could have arrived not as isolated strikes, but as clusters moving through the sky. Civilizations of that era, small, vulnerable, and dependent on stable climates, would have struggled to adapt. Agricultural systems failed, animal populations collapsed, and entire human communities may have perished. The planet itself remembers these swarms, written in ice cores, sediments, and fire scars. But for the humans who lived through them, only memory and myth survived. Other myths, from Sumerian flood stories to Polynesian legends of skyfire, suggest repeated awareness of catastrophic events. Recurrent themes emerge: fire raining from the heavens, the oceans surging, landscapes reshaped in a single day. Swarms provide a plausible mechanism. Multiple fragments, striking in sequence, could trigger cascading disasters. Tidal waves from ocean impacts, atmospheric dust dimming the sun, regional fires igniting simultaneously. The stories of the past may reflect a form of ancient science, encoded in narrative to preserve knowledge across generations. The consequences of such events are not limited to physical destruction. They ripple through culture, technology, and knowledge. Societies might lose agricultural techniques, architectural skills, or even written language. Entire philosophical and scientific traditions could vanish if the centers of learning are destroyed in a single cataclysm. What remains is myth, moral lesson, and fragmentary memory, an echo of a once thriving civilization undone by forces beyond comprehension. Swarm-related catastrophes also challenge our understanding of human resilience. Some communities survived, adapting to harsh post-impact climates. Others did not. Survival depended on mobility, resource management, and perhaps a measure of luck. Modern analogs remind us of our ongoing vulnerability. Volcanic eruptions, asteroid near misses, and climate shocks continue to test human systems. The patterns of history may not be coincidence. They may reflect recurring trials imposed by celestial events, cycles of destruction written in both geology and myth. Even more intriguing is the possibility that fragments trailing interstellar visitors, like 3I Atlas, could someday mirror past events. Observing such swarms gives us a lens into the past as much as a glimpse into the future. By studying their paths, composition, and potential for disruption, we learn not only about physics and astronomy, but about the fragility of civilizations and the impermanence of human achievement when confronted with the indifferent universe. The lessons of lost civilizations are sobering. Knowledge is fragile. Culture is delicate. And yet, their stories survive, encoded in myths, legends, and fragmentary records. They remind us that cosmic events have shaped humanity from the very beginning, leaving traces that science now begins to decipher. Perhaps we are the inheritors of knowledge, shaped not by deliberate teaching, but by survival through catastrophe, a testament to both chance and resilience. As we reflect on swarms, climate disruption, and the vanished civilizations of history, we recognize the interconnectedness of natural and cosmic forces. The sky is not merely a backdrop. It is an active participant in the fate of life on Earth. Past societies may have encountered these forces unknowingly, leaving us only stories to decipher. Today, as we monitor 3I Thale interstellar visitors, we are both observers and participants in a continuum that stretches across millennia. From the echoes of civilizations lost, we now turn to a deeper meditation. What if the patterns we see in history and myth are not merely accidents? What if the universe itself tests intelligence, resilience, and adaptation? In the next chapter, we explore alternative timelines, imagining worlds shaped by repeated encounters with swarms, and reflecting on the fragility and persistence of life in a cosmos of uncertainty. For millennia, humanity gazed at the sky with wonder, reverence, and fear. Stars guided our navigation, comets inspired awe, and meteors were warnings in motion. Yet only in the last century have we developed the tools to truly observe, measure, and prepare for threats from beyond our world. The appearance of interstellar visitors, like 3I Ateliers, reminds us that our fascination is inseparable from vulnerability. Modern planetary defense begins with observation. Ground-based telescopes, like Pan-STARRS and the Catalina Sky Survey, scan the heavens tirelessly, seeking fast-moving objects that might cross Earth's path. Satellites supplement these efforts, detecting thermal signatures and tracking near-Earth objects invisible to optical instruments. Yet despite technological leaps, gaps remain. A fragment of a swarm, the size of a small mountain, could pass undetected, arriving with little warning. The universe is patient, and our vigilance is never complete. Defense is not only detection, it is action. Concepts like kinetic impactors, exemplified by NASA's DART mission, demonstrate that we can alter the path of potentially hazardous objects. In theory, a carefully timed strike against a small asteroid can nudge it away from collision, buying Earth safety measured in years or decades. Yet swarms pose a unique challenge. Multiple bodies, traveling in unpredictable configurations, might require coordination far beyond any single mission. The idea of deflection extends into more speculative strategies as well. Gravity tractors that slowly tug objects off course, nuclear disruption to fragment threatening bodies, and advanced monitoring to anticipate trajectories years in advance. Each approach is grounded in physics, yet all confront limits, time, energy, and human coordination. The cosmos does not wait for diplomacy or technical readiness. And yet, planetary defense is not only a matter of science. Politics, economics, and international collaboration define the effectiveness of our preparations. Space is a shared domain, and no single nation can fully protect Earth alone. Agreements must be forged, resources allocated, and data shared. A swarm like Atlas reminds us that planetary defense is as much a human challenge as it is a scientific one. Coordination failures could turn theoretical protection into near-certain catastrophe. The psychological dimension is equally crucial. Awareness of vulnerability breeds both caution and anxiety. Will populations trust that governments and agencies can respond to threats beyond their imagination? Will scientific warnings translate into actionable policies? Eyes turned skyward are not merely watching objects. They are measuring our own readiness, our resilience in the face of uncertainty. History offers cautionary lessons. Civilizations have underestimated natural threats repeatedly, floods, volcanoes, and comets alike. Modern technology offers unprecedented awareness, yet the scale of interstellar anomalies dwarfs past experience. Swarms, with their unpredictable trajectories, challenge not only our engineering, but our imagination. They remind us that survival requires both foresight and humility. Education and preparation are part of the defense, too. Public understanding of cosmic risks, from asteroid impacts to climate perturbations induced by extraterrestrial events, strengthens resilience. Communities that understand the stakes and the limitations of early warning systems are better equipped to respond when anomalies arrive. A swarm may be patient, but human decision-making is fast, adaptable, and capable of mitigation if informed and coordinated. Consider the international implications. A swarm approaching Earth would demand unprecedented cooperation. Space agencies must share tracking data in real time. Military and scientific assets might be redeployed for observation or potential mitigation. Yet geopolitical tensions, differing priorities, and resource disparities could slow the response. In the best-case scenario, nations collaborate seamlessly. In the worst, bureaucracy and distrust could amplify the consequences of a single oversight. The technological aspect continues to evolve. New telescopes, AI-driven sky surveys, and deep space radar promise earlier detection. Simulations of swarm behavior and impact probabilities help refine defensive strategies. Even so, the universe's complexity ensures that uncertainty remains. Every new discovery, unusual acceleration, non-gravitational trajectories, unexpected clustering forces recalibration. The cosmos is a teacher of humility, reminding us that vigilance is an ongoing process, not a one-time achievement. There is also an ethical dimension to planetary defense. If interventions fail or fragment swarms unpredictably, we could inadvertently create new hazards. Humanity's first steps into cosmic protection are tentative, experimental, and sometimes controversial. Yet these decisions may define our species' future, whether we remain passive observers or proactive stewards, capable of surviving in a galaxy where swarms, like Atlas and its companions, traverse the void. In the end, eyes turned skyward are not just a symbol of awareness. They are a metaphor for responsibility. The cosmos tests both our ingenuity and our cooperation. Each fragment tracked, each orbit calculated, is a reminder that survival depends on foresight, vigilance, and humility. Humanity's readiness is measured not only by technology, but by imagination, collaboration, and the willingness to prepare for the unimaginable. As we continue to scan the heavens and refine our defense strategies, the line between observation and action blurs. The swarm may be years away or centuries. Its impact may be minor or catastrophic. But the exercise of watching, measuring, and planning is itself transformative. It shapes the way we understand Earth, the solar system, and our fragile place within it. From the challenges of preparation and defense, we now turn to the fragility of systems, how even small disruptions from cosmic visitors can ripple through food chains, economies, and infrastructure, revealing the delicate balance upon which civilization rests. On a crisp May morning in 1780, the residents of New England woke to a sky that defied all expectation. Birds froze mid-flight, roosters hesitated to crow, and the sun itself seemed swallowed by an unnatural darkness. For hours, the world was cast in a dim, eerie twilight, as if night had arrived without warning. People lit lanterns in the middle of the day, fearful that the end of the world had come. They called it the Dark Day, a mystery that has haunted historians and scientists ever since. Eyewitness accounts describe a sky thick with smoke and haze, though no forest fires were reported nearby. The darkness stretched across Massachusetts, Connecticut, New Hampshire, and even parts of Canada. Farmers halted their work. Congregations prayed in churches. The air seemed heavy with both fear and anticipation. Contemporary explanations ranged from divine punishment to climatic anomaly, yet none could fully account for the sudden and widespread obscuration. Modern science attributes the event to a combination of forest fire smoke from distant regions and unusual atmospheric conditions. Yet the intensity and persistence of the darkness suggest that other mechanisms could have amplified its effect. One particularly compelling idea, when viewed through the lens of cosmic swarms, is that extraterrestrial fragments may have contributed. A cluster of small meteoroids or comet fragments passing through the upper atmosphere could have temporarily increased particulates, dimming sunlight in a manner reminiscent of volcanic haze. Imagine a swarm, tiny yet numerous, moving silently across the sky. Each fragment interacts with the atmosphere, creating dust, smoke, and fine particles that linger. The cumulative effect, while subtle, could transform noon into near night. It would be a cosmic whisper, a fleeting shadow cast by the universe itself, reminding humanity that the heavens are not always predictable or passive. The dark day, brief and contained, serves as a microcosm of larger possibilities. If a single swarm can dim the sun for hours, larger clusters, composed of heavier fragments, could disrupt climate systems for weeks, months, or even years. Even today, scientists model the potential for small atmospheric obstructions to trigger temporary cooling, reduced photosynthesis, and cascading ecological effects. In 1780, people experienced a hint of this phenomenon without the benefit of modern understanding. There is a poetic resonance in this tale. Communities confronted an inexplicable darkness, their imaginations bridging the gap between reality and myth. Some attributed the event to supernatural forces, others to celestial warnings. The line between observation and interpretation blurred, as it has throughout history, whenever the sky behaves unpredictably. Viewed through the lens of interstellar swarms, the dark day becomes more than a historical curiosity. It is a reminder that Earth's climate is sensitive to even minor perturbations. Swarms like those potentially trailing 3Ia Lax are not necessarily destructive by mass alone. They can act indirectly, altering atmospheric conditions, blocking sunlight, or depositing dust and gases that affect weather patterns. The cosmos has its ways of leaving fingerprints, sometimes subtle, sometimes catastrophic. The dark day also illustrates human response to sudden, unexplained phenomena. Communities reacted with fear, improvisation, and ingenuity. Fires were lit to illuminate homes, bells rang in alarm, and prayers were offered for protection. Observation and interpretation went hand in hand, even in the absence of scientific instruments. This interplay of perception and reality underscores the importance of vigilance in the present day. Our technology may detect threats, but human judgment, interpretation, and preparedness remain vital. We are reminded that the universe is neither malicious nor benevolent. It is indifferent. Swarms of fragments, darkening skies, and temporary eclipses are not moral events. They are natural consequences of cosmic mechanics. Yet their impact on life, on psychology, and on societies can be profound. The dark day serves as a lens to explore this delicate balance. One day, an event may seem merely strange. The next, it could cascade into wider consequences. Even centuries later, the story of the New England dark day resonates because it captures the fragility of our assumptions. The sun rises and sets without notice, day turns to night predictably, and yet, in moments of cosmic alignment, all of that certainty can vanish. A fragment swarm, passing unnoticed beyond the horizon, could replicate this experience on a far grander scale, reminding humanity of its vulnerability to forces both subtle and immense. As we reflect on the dark day, we see echoes in other historical and geological records. Brief periods of darkness, anomalous weather, and sudden climate shifts. Could these have been the whispers of cosmic visitors, long before modern astronomers had telescopes and radar? Perhaps. Or perhaps the dark day remains a singular event, a cautionary tale of how easily the ordinary can be transformed into the extraordinary. From the eerie shadow of the dark day, our gaze now moves to the great filter, exploring why civilizations may vanish under cosmic pressures, and how the universe's trials may be both natural and instructive, shaping the trajectory of intelligence across the stars. We have traced the paths of interstellar travelers, examined the fragments trailing them, and glimpsed the ways they might shape life on Earth. And yet, a single persistent question remains. Why? Why do these objects wander through the void? Are they merely accidents of cosmic evolution, random debris cast off from distant stars? Or do they carry intention, subtle signals encoded in mass, trajectory, or timing. The universe does not answer easily. In one sense, a swarm is a natural outcome of gravitational chaos. Stars are born in clusters, planetary systems eject material, comets fragment, and over millions of years, interstellar wanderers emerge. In this view, Atlas and its companions are no more deliberate than a pebble carried by a river, inevitable, indifferent, and untargeted. Each fragment moves according to physics alone, yet from our vantage point, patterns emerge. And yet, the human mind struggles with randomness. History teaches us to seek meaning, to interpret signals, to read intention even where none exists. Could these wandering fragments be more than mere rocks? Some propose that they are messages in motion, designed to be noticed by civilizations capable of perceiving them. The very clustering of fragments, their strange accelerations, and unexplained trajectories could be an elaborate signal, one we have only just begun to comprehend. This idea touches the edges of the great filter, the concept that advanced civilizations may routinely vanish under cosmic pressures. Are swarms a natural hazard, an unavoidable gauntlet of the universe? Or are they tests, a subtle sieve to determine whether intelligent life survives long enough to reach a stage of resilience and understanding? The answer is unknowable, yet it forces contemplation. Each object we track is both a threat and an invitation, a glimpse into the mechanics of the cosmos and perhaps into its intentions. Philosophically, the question deepens. Are we actors on a stage, guided only by the laws of physics, or participants in a grand experiment, where the universe itself plays the role of examiner? Some thinkers suggest that intelligence might exist not just in life, but in structures and systems far beyond our comprehension. Swarms could function as natural or artificial beacons, markers for observation, or probes sent across vast distances. Every orbit, every cluster, may encode data, deliberately or by consequence, waiting for a civilization like ours to interpret it. Consider the alternative: swarms as traps, fragments from distant planetary systems, moving with precision we cannot yet measure, might appear random, but in fact constitute hazards engineered by natural selection on a cosmic scale. Civilizations that fail to detect or deflect these objects do not survive to leave a mark. This is no malevolence, no consciousness directing malice, only consequence. The universe selects for resilience, and swarms act as both teacher and arbiter. Humanity has always framed the unknown in myth and metaphor. Comets, meteors, and eclipses were once seen as omens or divine tests. Perhaps the universe is indifferent, yet the pattern of observation, warning, disruption, adaptation remains. Each civilization that reaches a stage of technological sophistication must confront threats from beyond its atmosphere, and each failure leaves only mystery. Swarms, in this sense, are part of a cosmic pedagogy, subtle, patient, and profound. Science offers a different perspective. Trajectories can be calculated, velocities measured, and potential collisions modeled. Observatories scan the sky for fragments, and simulations predict outcomes of multiple impacts. We are learning to anticipate, to prepare, and to intervene. Yet even the most sophisticated science cannot answer the deeper question of purpose. Nature obeys laws, but the meaning we assign remains ours alone. Are swarms natural debris, or are they agents in a theater that stretches across galaxies and epochs? The question invites reflection on human perception and humility. If swarms are accidents, they remind us of fragility. Life exists in a precarious balance, and intelligence is a temporary fluke in a vast, indifferent cosmos. If they are messages, they challenge our awareness, inviting curiosity, understanding, and perhaps communion with forces beyond our ken. And if they are tests or traps, they underscore the stakes of vigilance and foresight, of imagination and science working together to ensure survival. There is also a temporal dimension. Swarms traverse light years, carrying consequences that may unfold centuries or millennia after their origin. Observation is always delayed. Understanding is always partial. Humanity stands at the edge of comprehension, interpreting a cosmic script written in silence, dust, and motion. Each fragment tracked, each cluster analyzed, is a step toward understanding a narrative that may span billions of years, far beyond our individual lifetimes. Ultimately, the deepest question is not answered by physics, mythology, or speculation alone. It is an invitation to wonder, to engage with uncertainty, and to recognize our place within a universe that is simultaneously nurturing and indifferent. Atlas and its companions remind us that the cosmos is not passive. It is dynamic, unpredictable, and perhaps, in ways we cannot yet measure, communicative. From the contemplation of cosmic intention and existential reflection, our journey now turns to the open ending, a meditation on creation and annihilation, on the fragility and resilience of life, and on the lingering question, what is the worst-case scenario, and could it also be the best? As night falls across the planet, the vast canvas of the cosmos unfurls above us, indifferent yet profoundly mesmerizing. Stars puncture the darkness like distant lanterns, each one a sun, a beacon, a possibility. Somewhere far beyond, Three-Eye Atlas and its trailing swarm drift silently, moving along trajectories calculated in eons, unaware of the eyes that now track them. Yet for us, their passage is profound, both a marvel and a warning. We have followed the object from its discovery, traced its mysterious companions, and contemplated the havoc even small fragments might unleash. We have peeked into history, myth, and the fragile record of civilizations that once looked skyward, perhaps seeing swarms just as we do now. And still, as Atlas glides deeper into our system, questions linger. Was this a chance encounter? A cosmic accident written in the cold arithmetic of gravity? Or is there something more? A subtle message, a test, a brush of intelligence that challenges our understanding of the universe? The silence of space is deceptive. Between the celestial mechanics and the measured movements of swarms lies possibility, disruption or insight, catastrophe or illumination. We have speculated about climate upheavals, lost civilizations, and the potential for extinction. Yet equally, there is wonder, the knowledge that we can observe, calculate, and even, perhaps, respond. Humanity is no longer completely passive. Our gaze, our instruments, our imagination reach outward in ways unimaginable to previous generations. There is a beauty in that awareness. Even as Atlas passes unseen by the unaided eye, telescopes and radar reveal patterns, velocities, and compositions that speak to the creativity of the cosmos. Each fragment in the swarm, however small, is a messenger of physics, energy, momentum, and time encoded in motion. Yet the narrative we construct around it, danger, curiosity, all remains uniquely human. We interpret the cosmos in our own language, translating light, shadow, and trajectory into story, lesson, and reflection. Our reflections deepen when we consider scale. Atlas and its companions are minuscule relative to the vastness of the solar system. They pass unnoticed by most, yet their potential significance is immense. In them, we see analogs of ourselves, small, vulnerable, yet capable of observing, understanding, and reacting. The universe, in its grandeur, offers perspective. We are simultaneously fragile and capable, transient and enduring, insignificant yet conscious. History whispers caution. From the New England dark day to the younger Dryas, from myths of the destroyer comet to Plato's Atlantis, humanity has glimpsed the consequences of forces far beyond immediate comprehension. Swarms may arrive again, or perhaps never return for millennia. Still, each observation is a lesson in humility and preparation. Every orbit charted, every fragment tracked, is a reminder of the universe's duality, creative and destructive, indifferent and instructive. Philosophically, the presence of a swarm invites contemplation. Are we being observed, tested, or merely brushed by the random motions of matter? The question is unanswerable, yet it is essential. To wonder about intent in the cosmos is to confront the limits of human knowledge, to embrace curiosity as a guiding principle. The uncertainty is itself instructive. The absence of certainty fosters vigilance, imagination, and reverence for the vast scales of space and time. The cinematic moment is tangible. The swarm slips past Earth's orbit, silent and invisible to most, yet its trajectory leaves an imprint on the human mind. The night sky, usually so stable and predictable, feels alive. Shadows and light, science and myth converge in thought. It is a meditation on fragility, resilience, and awareness. Watching Atlas is not merely an act of observation. It is a dialogue conducted in motion, time, and consequence. In this reflection, the duality of perspective is clear. From a cosmic viewpoint, swarms are indifferent, mechanical, predictable in the language of physics. From a human viewpoint, they are symbols of risk, of wonder, of questions that surpass generations and civilizations. We assign meaning, not because the universe demands it, but because we must. Meaning sustains curiosity, vigilance, and hope. And yet, despite all we know, there is unease. The possibility of chaos remains. Even small fragments could ripple through climate, ecology, and society. Even minor miscalculations could have cascading consequences. The awareness of vulnerability coexists with fascination, creating a tension that has defined human interaction with the unknown since our ancestors first looked upward. As our gaze rises to the stars, the camera pans along the swarm's silent trajectory. Light from distant suns reflects subtly off icy surfaces, tracing paths that took millions of years to intersect with our neighborhood. Atlas and its companions are both ordinary and extraordinary, natural objects shaped by the laws of physics, yet capable of inspiring awe, fear, and contemplation in those who observe them. Perhaps this is the ultimate lesson, that the universe is neither benevolent nor malevolent, but immensely complex, indifferent, and patient. Humanity exists for an instant on a pale blue dot, yet possesses the consciousness to interpret motion, to ask questions, to prepare, and to marvel. The swarm's passage reminds us that observation is an act of both humility and power, a recognition of our vulnerability, and a celebration of our capacity for understanding. The night deepens. Earth rotates beneath the stars. LALACE drifts further into the solar system, eventually beyond the reach of most instruments. Its companions follow, and the sky resumes its familiar rhythm. Yet something remains altered, the awareness that the heavens are alive with motion, consequence, and possibility. Humanity has looked up and seen not only objects, but a reflection of its own fragility and curiosity. As the final images fade, the question lingers. Are we merely spectators of chance, or participants in a cosmic narrative, brushed by the passage of objects that have traveled for eons to meet us for a fleeting moment? The universe remains a theater of creation and annihilation, warning and wonder. And in that uncertainty lies both the thrill and the responsibility of consciousness beneath the stars. The cosmos is patient, silent, and immense. We may never know the full story of 3i Atlas, its swarm, or the meaning of their journey. But we watch, we measure, and we reflect. The universe is vast, and we are small, but through observation, imagination, and understanding, we touch the infinite.